Let's look at methods of solving exponential equations. Remember, to be an exponential equation, you're going to see a variable in the exponent. So our first method of solving is called the uniqueness property. And the uniqueness property basically says that if you have a base raised to the power of x, and it's equal to the same base raised to the power of y, so this means that the bases are the same. B is for base, so the bases are the same. If the bases are the same, then you can set the exponents equal. So we can say x is equal to y. That's called the uniqueness property. Now that's also called the equivalence property in some textbooks, and some people just refer to this technique as getting common bases. So these three phrases all mean the same thing. You're basically getting the bases to be the same. Here's a quick example of an equation where you could use the uniqueness property. So if we were trying to solve the equation 2 to the x power is equal to 32. So the base right now on the left side is 2. So on the right side, we have a 32, and we could rewrite 32 with a base of 2 because 32 is the same as 2 to the 5th power. So see, by rewriting 32 as 2 to the 5th, we now have common bases. We have the same base on the left as we do on the right. And if the bases are the same, then this uniqueness property says we can set the exponents equal. So therefore, our answer to this equation would be x is equal to 5. Now, our second method of solving, let me show you the example first, is for when we cannot get the same base on both sides. So for example, if you were given 2 to the x power is equal to 33. There's no way we can write 33 with a base of 2. So the uniqueness property doesn't work. In this situation, we want to isolate the exponential quantity and then rewrite the equation in logarithmic form. So right now, our exponential quantity, it's already isolated. That means the 2 to the x is already by itself. So to solve this, we write this in log form, which would be log base 2 of 33 is equal to x. We solve for x, the exponent, by rewriting the equation in logarithmic form. So written out, this would look like this. If you have some base raised to a power, I'll write my power as p, and if that is equal to, we'll just call it m, and we cannot get the bases to be the same, then when we rewrite this in logarithmic form, we will have log base b of m is equal to the exponent, which is p. We can solve for the exponent by rewriting the equation in logarithmic form. Then our third method of solving is called taking the log of both sides. This happens to be my least favorite. I'm going to always encourage you to try to use the first two methods, which would be the uniqueness property, and then isolating the exponential quantity and rewriting the equation in log form. But I will also show you some examples where you can take the log of both sides if you prefer. Last thing before we jump into a bunch of examples, just remember that exponential functions, they do not have any domain restrictions. So that tells you that you do not have to worry about checking for extraneous solutions. Since the domain for exponential functions, the domain is all real numbers, that means we will not have any domain restrictions. So for exponential equations, you will never have extraneous solutions.